Our next speaker is Frank Rarity, who has joined the GSSA in the last year or so to work on, change my glasses, to work on the SADM, the South Australian Discovery Mapping Project, and Frank is taking the lead in the compilation team on the eastern Nuyts Domain of South Central Gawler Craton. Frank's background again is heavily into sedimentology. He's worked as a casual lecturer at Flinders Uni and a consultant geologist in South Australia, postdoc at Adelaide Uni, and hails from the UK, where his focus was on tectonic stratigraphy of the Suez Rift and a master's in geodesy. So, thank you.
Thank you very much for the kind introduction. So I'm going to present a summary of map compilation within the eastern, oh, you don't see it on there, I've got to look up there. Within the eastern Nuyts Domain of the Central Gawler Craton. As Liz mentioned, this forms part of the South Australia Discovery Mapping Project, also referred to as SADM. There we go. In this talk, I will focus on the aeromagnetic interpretation and structural mapping of the Yarlbrinda Shear Zone. We will investigate the movement history and timing of deformation and explore potential relationships between structural geometry and mineral prospectivity. So the TMI image shows the extent of the GCAS Aeromag survey acquired in 2019. This represents the sort of framework for our map compilation. The red box highlights the location of the eastern Nuyts Domain within the sort of regional context of the Gawler Craton. Zooming into the Nuyts Domain, we can make out the main structural elements that bound that domain. To the north, there is the major sort of crustal scale shear zone, the Yarlbrinda Shear Zone, separating the Lake Harris greenstone belt and the Archean rocks of the Wilgina Domain from the Paleo to Mesoproterozoic rocks of the Nuyts Domain. To the west, we have the Kurabi Shear Zone and the Fowler Domain. And to the east, the Gawler Range volcanics largely overlie and largely obscure the boundary. The Kurabi Shear Zone and the Yarlbrinda Shear Zone are also prominent features on the Aeromag, with the Yarlbrinda Shear Zone also forming a partial boundary to the domain. The Nuyts Domain is dominated by Paleo to Mesoproterozoic felsic intrusive rocks, often forming large elliptical plutons, as you can make out on the aeromagnetic imagery. These are variably deformed. They're often dissected by regional low-grade shear zones or locally intruded along the shear zones. There's 5 main phases of magmatism that have been identified, from the late Paleoproterozoic Ping-Pong Suite and Tunkilia Suite, through St. Peter Suite, to the Mesoproterozoic Gawler Range volcanics and Hilteba Suite, and then the S-type Mungila granites, which are localized to the both along the Kuniba fault zone and to the west of the Kuniba fault zone. With the exception of the Gawler Range volcanics, almost all of these units are granitic, with similar lithological contrast, making it challenging to identify the different suites using the aeromagnetic imagery alone, despite its amazing resolution. In order to help characterize the aeromagnetic imagery, we've used a combined approach. With the extensive sort of surface geology, the cover. The drill hole data set is our first point of reference. And from initial appearance, it looks like we have excellent coverage. However, many of these don't quite intersect the basement. And of those that do intersect the basement, even fewer have any core. Despite this, we do have a very good geochronology data set acquired from both the drill holes and outcrop, which have been invaluable for characterizing the aeromagnetic imagery. Geochemistry has also been very useful for mapping the plutons. But as you can see, gaps still remain in the data. Recent sampling campaign with geochronology analysis currently undergoing at the moment helps fill some of these gaps. We'll now take a closer look at the geology with a short sort of fly through the aeromagnetic imagery. It works. Okay, so the oldest units in the area, the Tunkelia suite and locally Ping Pong suite, are localized to the... Oh, hold on, sorry, pushed the wrong one. Let's start again. That's the laser. So the oldest units, the Tunkelia suite and locally Ping Pong suite, are localized to the Yarlbrinda Shear Zone. Here. It's a north-south striking demagnetized zone. It doesn't represent a single discrete shear zone, rather a series of linear demagnetized bands. Over to the west, we have a broad area dominated by the St. Peter suite, represented by these sort of moderately magnetic plutons and great structural complexity. Now we've just spun around, we've headed over to the east. The area is dominated by the Gawler Range volcanics that have a distinct sort of stippled appearance in the aeromag imagery and long curvilinear faults and volcanic fronts. These and the other suites are intruded by the Gawler Range, by the Hilteba suite granites, which have a generally low magnetic cores and high magnetic rims. We can check the sort of the aeromag interpretations against outcrop where available, like here where the Yana granite intrudes felsic rhyolites and dacites of the Gawler Range volcanics. Mapping started by picking structures, so structure lines, trend lines, and boundaries on the aeromagnetic imagery. As mentioned, as well as picking these features on the aeromagnetic imagery, we've tied where possible to outcrop, also using gravity data to discern like deeper features. Once we've picked the lines, interpreted the sort of linear features, we can attribute these features, and we can also assign geological units, and then we can generate our polygons to create our final map. The map compilation process and the attribution of the features, as Rashid illustrated, helps understand the sort of deformation history of the area. So in this small case study of the Yarlbrinda Shear Zone, the earliest fabrics that we make out on the aeromag imagery, which are the north-south to north-north, west-south, southeast foliation, may be attributed to the Tunkelia suite at the time of Tunkelia suite emplacement. However, cross-cutting relationships make this difficult to confirm. Deflection of the aeromagnetic foliation along with outcrop observations of John Stewart and Gary Ferris, strongly support a dextral sense of shear for the main shearing event in the Yarlbrinda Shear Zone. We see a localized west side up sort of thrusting, suggested by these sort of steeply dipping stretching lineations. This is to the west of the shear zone, whereas to the east we see a continued dextral sense of displacement, evidenced by truncation of this north-south fabric. The Yarlbrinda Shear Zone is cross-cut by northeast trending structures which show a sinistral sense of displacement. This change from dextral north-south shearing to northeast trending sinistral shearing suggests a change in the shortening direction from roughly east-west to a more north-south orientation. This is thought to be concurrent with early emplacement of the Hilteba suite and probably early dextral displacement on the Yarlbrinda Shear Zone to the north. Finally, we see a sort of beheading or truncation of those northeast sinistral faults by some southeast orientated dextral shears. We also see a nice foliation in these gneissic units here, supporting that late stage of dextral shearing, likely representing splays from the east-west Yarlbrinda Shear Zone to the north. In terms of timing, the main shearing event in the Yarlbrinda Shear Zone is bracketed by the late Paleoproterozoic lithology within the shear zone and underformed Hilteba granites, suggesting that the main high-grade ductile deformation was likely predating the Hilteba granites, but the Hilteba granite emplacement and the later deformation were broadly concurrent. So we can place this deformation history within the sort of more regional context and tie it to major tectonic events. So the main shearing event within the Yarlbrinda Shear Zone was largely concurrent with the earlier Eulerian, also referred to as the Waterkern in southeast Gawler, which is roughly concurrent with the emplacement of the St. Peter suite. So our structural kinematics at this time was likely complicated by the emplacement of the arc-related St. Peter suite. Switch from roughly east-west to north-south shortening during the early Carrara time is consistent with what we see in the Mount Woods area in northern Gawler. Interestingly, in that northern Gawler area, as Rashid mentioned, the earlier sort of east-west early Eulerian or Waterkern event is poorly recognized in the geological records. So it's almost like with this detailed studies such as these help piece together the regional picture. Last slide. Shear zone hosted gold prospects occur at Tunkilia and Nucula to the south. Close relationships are identified between structural geometry and the patterns of mineralization and alteration. So the sheared and brecciated Tunkillia suite represent the host rocks, with gold anomalism thought to be associated with Hilltop and emplacement in GRV. Recognizing the partitioning of strain and the different shear bands being active at different times can help explorers in the area, and also explorers potentially looking at similar settings elsewhere, with the alteration and gold anomalism associated with these narrow shear parallel demagnetized bands. So in summary, structural mapping and aeromagnetic interpretation of the Yarlbrinda Shear Zone indicates a complex evolution involving several major magmatic and deformational events. The mapping helps inform the movement history and timing of deformation on the Yarlbrinda Shear Zone, but also contributes to better understanding of the regional tectonic evolution. And finally, close relationships are identified between structural geometry and patterns of mineralization and alteration relating to gold anomalism. Thank you.